A startup founded 18 months ago just shipped humanoid robots to a Fortune 500 company. Not prototypes, not demos. Production units deployed in live industrial environments doing real work. The company is Noble Machines. The robot is called Moby, and the team behind it came from SpaceX, Apple, NASA, and Caltech. That alone would be a big story. But this week also saw someone test an entire operating system written without a single line of human code, vibe-coded from scratch by AI. And the results tell you a lot about exactly where machine intelligence actually is right now. Let's get into it. On March 3rd, Noble Machines, formerly known as Under Control Robotics, officially emerged from stealth. The company was founded in 2024 by a team of engineers from Apple, SpaceX, NASA, and Caltech, led by CEO Wei Ding. Their robot Moby is a general-purpose humanoid designed for hazardous and physically demanding industrial work, manufacturing floors, construction sites, logistics hubs, energy facilities, and semiconductor fabs. Moby can lift and carry up to 27 kilograms, about 60 pounds, and runs for 5 hours on a single charge. It's powered by a single NVIDIA Jetson or an Edge AI computer. The key design choice is that Moby is built for real terrain. Stairs, scaffolding, cluttered floors, not polished lab environments. And operators can train it on new tasks in hours, using natural language instructions and physical demonstrations, not months of programming. Noble Machines has already shipped and deployed these robots to a Fortune Global 500 customer, 18 months from founding to Fortune 500 deployment. They're working with industrial partners including Schaeffler, AD-Link, and Solomon to validate more deployments. Schaeffler's head of Humanoid Robotics Americas specifically cited Moby's high payload capacity and seamless implementation as reasons for their collaboration. But Noble Machines wasn't operating in a vacuum this week. At Korea's Automation World 2026, humanoid platforms from Agibot, Boston Dynamics, Unitree, and Leju were all on display, multiple competing systems jockeying for industrial customers. Google officially absorbed its Intrinsic Robotics AI unit, consolidating its bet on industrial robotics intelligence. Mass robotics startups have now surpassed $2 billion in total funding. And Physical Intelligence unveiled Multi-Scale Embodied Memory, a system that gives robots a 15-minute context window for complex multi-step tasks. Solves a fundamental problem. Robots have historically had a few seconds of high-fidelity visual memory, or nothing at all. Physical Intelligence combines short-term visual tracking with long-term natural language narrative, so a robot can now clean an entire kitchen, cook a grilled cheese sandwich from scratch, or correct its own mistakes mid-task. In one demo, a robot failed to grasp a chopstick from an unusually low table, remembered the failure, adjusted its grip height, and succeeded on the second attempt. Physical Intelligence raised $600 million in late 2025, and is where that money is going. The robotics industry has had a credibility problem. For years, every conference had humanoid demos that looked impressive on stage and went nowhere after. What changed this week is volume and convergence. Noble Machines didn't announce a robot, they announced a deployment. They already have units working at a Fortune 500 site. Korea's AW 2026 wasn't one humanoid getting attention, it was 5 or 6 competing platforms from companies across 3 continents. Google didn't start a robotics project. They absorbed an entire AI team into their core infrastructure. And Physical Intelligence's addresses maybe the single biggest practical limitation of robotic autonomy, that robots forget what they were doing 10 seconds ago. A 15-minute context window doesn't sound dramatic until you realize that's the difference between a robot that can pick up a single object and a robot that can complete an entire job. Wei Ding, Noble's CEO, framed it plainly. Customers are rethinking their operations because general-purpose robots that collaborate with people are now real. The timeline for industrial humanoid adoption just compressed from eventually to now, if you have the budget. The fact that this is happening across multiple companies simultaneously is the signal. No single company made this happen. The infrastructure, compute, AI models, hardware supply chains reached a tipping point all at once. Noble Machines will be doing live demos at NVIDIA GTC later this month. Booth 3303, and the NVIDIA booth. Watch for deployment numbers. If Fortune 500 customers start publicly naming themselves as Noble Machines clients, that's the signal that industrial humanoids have crossed into mainstream procurement. And keep an eye on Physical Intelligence. They've said scaling memory beyond a single episode into weeks or months is the next major frontier. 15 minutes is the floor, not the ceiling. So physical AI is reaching the point where robots can learn tasks in hours and remember them for minutes at a time. That raises an obvious question about AI capability in general. If you gave an AI total control over building something complex from scratch, no human engineering, No hand-holding. How far could it actually get? Someone tested exactly that. And the answer is fascinating. On March 4th, Hackaday published a detailed test of Vibe OS, a Unix-like operating system built entirely through vibe coding. If you're not familiar with the term, vibe coding means using AI to generate all the code based on natural language prompts, with minimal or no human programming. The developer describes what they want, the AI writes it, and ideally you get working software. Vibe OS is an open-source project on GitHub under the username Viral Code. It advertises itself as a from-scratch operating system with ARM64 and x86_64 support, a full graphical user interface, TCP/IP networking, a virtual file system, and even a built-in copy of Doom. The project claims over 25,000 lines of C and assembly, all AI generated. A YouTuber named Tyrimid decided to put Vibe OS through a structured set of real-world tests. The kind of things you'd expect any operating system to handle. Boot up, run applications, connect to the internet, manage files, play a game. The results were a clean split between simple and complex. Vibe OS boots. It actually boots to a functional desktop with a macOS-inspired GUI. That alone is remarkable, an AI-generated operating system that successfully initializes hardware, loads a kernel, and presents a graphical interface. It can run a note-taking application. It can run Snake, the classic game, though Tyrimid noted it ran poorly. Everything beyond that failed. Networking, advertised as a full TCP/IP stack, didn't work at all. File deletion broke. And Doom, which was included in the OS's own files and prominently advertised as a feature, wouldn't load. The operating system couldn't handle its own bundled software. Hackaday's write-up called it a vibe-coded confabulation, an OS that presents the appearance of functionality but collapses under any real demand. The community reaction on Hacker News was split. Some pointed out that getting a bootable OS from AI prompts at all represents genuine progress. Others argued that vibe coding produces exactly this kind of surface-level plausibility, things that look right but have no structural integrity underneath. Vibe OS is the most concrete benchmark for vibe coding's actual capabilities that anyone has produced. Not theoretical arguments about whether AI can write code, a real testable artifact with clear pass-fail criteria. And the results map almost perfectly onto what experienced engineers would predict. AI is excellent at generating code for well-defined, self-contained tasks with abundant training data. Booting an OS, rendering a GUI, running a simple game loop, these are patterns that exist across thousands of open-source projects. AI models have seen them a million times. Networking, file system operations, and complex game engines require something different, understanding how components interact across layers of abstraction, handling edge cases that aren't in the training data, and maintaining consistency across a system that has to work as a coherent whole. That's where vibe coding breaks. The ceiling is rising. A year ago, vibe coding a bootable OS would have been unthinkable. The fact that 25,000 lines of functional enough C and assembly came out of AI prompts is a real capability milestone. But the gap between boots to a desktop and works as an operating system is enormous, and that gap is exactly where human engineering judgment lives. Systems thinking, debugging across abstraction layers, handling the interactions between components. That's the hard part of software, and AI can't fake its way through it yet. The Vibe OS GitHub repo is still active, and the Hacker News community has suggested the next logical test is vibe coding a web browser, which would stress test AI's ability to handle the kind of deep protocol and rendering complexity that broke networking. If someone manages to vibe code a browser that can actually load a web page, that would meaningfully shift where the ceiling sits. Until then, Vibe OS is the scoreboard. Boot and GUI. Yes. Anything that requires systems-level coherence. No. Robots that remember what they were doing 15 minutes ago. Operating systems written by machines that forget how networking works. The gap between what AI can build and what AI can run keeps getting weirder. The question worth sitting with. A year from now, which of these limits will still hold? If you want to keep tracking that question, we cover AI and tech news here every day. Hit subscribe, and I'll see you in the next one.